Alright, what's up everybody? This video we are going to do integrals using partial fraction decomposition. Alright, so let's go ahead and get started. So we've got f of x is equal to p of x over q of x, okay? And p and q are polynomials. We have a rational expression. If f is improper, okay, so if this function f of x is improper, that means the degree of polynomial p is greater than or equal to the degree of the polynomial q. We must divide q into p until a remainder r of x is obtained such that the degree of r, the remainder, is less than the degree of q. So that would give us like f of x which is equal to p of x over q of x. And remember, the degree of p is greater than or equal to the degree of q. That would equal s of x plus r of x over q of x. And s and r are polynomials. All right. So s would be the quotient when you divide q into p, r is your remainder, and q is the divisor. All right, so let's look at an example. We want to integrate x cubed plus x over x minus 1. All right, so you can see here the degree of the numerator is larger than the degree of the denominator, and that's all that means up here. See, if the degree of p is greater than or equal to the degree of q, which you could read it as the degree of the numerator is greater than or equal to the degree of the denominator, then we have to divide. So dividing this, we get x minus 1, and then we have x cubed. Now remember, when you're doing long division, remember you have to write it in descending powers, and we're missing an x squared term, so we'll put that x squared term in as 0 times x squared plus x. Now I'm not going to get too much into dividing these things. You should already know how to do this. If not, if you need more explanation on dividing the polynomials, just go to my YouTube channel and type in polynomials long division. Search my channel for that, and I have a video on it. So what do we have to multiply to x to get x cubed? Well, that's x squared. And then we multiply the x squared to the x minus 1, so that's x cubed minus x squared. And then remember, you change the sign of the bottom terms and you add. And so this would be x squared, bring down the next term, plus x. Then what do we multiply x to get x squared? Well, that's x. And then x times this, that's going to be x squared minus x. And then we're going to change the sign of each term and add. So that's 2x. All right, and then what do we multiply to x to get 2x? Well, that's a 2, so plus 2. So 2 times x minus 1, that's 2x minus 2. And look, you can write this as a plus 0 out here, and you can bring down that 0. And then we're going to change the sign of each term and add, and so that's 2. All right, and so now what we get is we get the integral of x cubed plus x over x minus 1 dx is equal to, so it's when I divided the x minus 1, this x minus 1 into x cubed plus x, I get, well, I forgot my integral symbol. That's going to be the integral of, that's going to be x squared plus x plus 2 plus the remainder over the divisor. And now we're ready to integrate this thing. So we can just integrate each term. And so that's going to be 1/3 x cubed. Remember, add 1 to the exponent, multiply by the reciprocal of the new exponent. Plus, and then we integrate the x. That's going to be 1/2 x squared. And then the antiderivative of 2 is 2x plus. Now this one, you should recognize this. This is going to be 2 natural log absolute value x minus 1 plus c. And just real quick on this 2 over x minus 1, let me just come down here real quick and show you. So if I write that, I can bring the 2 out and write that as 1 over x minus 1 dx. Then if you let u equal x minus 1, du is equal to dx. And so you can see we've got the 1 dx here, and that's what this is, 1 dx. So that'll be replaced with du. So that's going to be du over, and in the place of x minus 1, we put u. And so that's 2 natural log absolute value of u. And then you're going to take the x minus 1 and plug it back in for u, and that's where we get that from. All right. So on this problem, we didn't have to use partial fractions. Okay, and that's a key point in this section here. Okay, so let me just talk about that for just a minute. So just because you have a fraction like this doesn't mean you're going to always use partial fractions. Okay, remember, typically in calculus, this method here, partial fractions, is usually in chapter 7, and you also learn the trigonometric integrals. You learn integration by parts, trigonometric substitution, partial fractions. Okay, keep in mind, this is not your first choice to integrate. Okay, those methods there. You wanna try to integrate things using what you had in what you got in the tables. You know, when you first learned how to integrate, it's typically chapter 5 in a calculus book. Okay, you want to do those methods. You don't want to do the methods that I'm doing in this video or the other videos, integration by parts, trigonometric substitution. Okay, try not to do those. Only use those methods if you have to. Okay, so the first thing you look at is say, okay, can I integrate this using a basic, like the power rule or something like that? Can I do it with one of those things that I learned at first? And then if you can't do that, then you come to this stuff. Okay? All right, let's look at this. All right, so it says the denominator q of x is a product of distinct linear factors. Okay, so we have our denominator q of x is this, a1x plus b1 times a2x plus b2, so on. All right, where no factor is repeated and no factor is a constant multiple of another. In this case, the partial fraction theorem states that there exists constants a1, a2, all the way to a sub k, such that r of x over q of x is equal to a1 over a1x plus b1 plus a2 over a2x plus b2, and so on. All right, so this right here tells us how we rewrite this fraction here. So let's look at an example demonstrating that. All right, so the first thing we want to do is we want to take the denominator. Let me change colors. So we got 2x cubed plus 3x squared minus 2x, and we want to factor this thing. So we're going to factor out of x first. And this is going to factor into 2x minus 1 times x plus 2. All right. So all we did is we took the denominator and factored it. And so now we've got x squared plus 2x minus 1 over, and then I'm going to write this denominator, but I'm going to write it factored. All right, so now we've got to rewrite this, okay? So we're going to have a over x, say a over this, over the x, plus b over 2x minus 1, plus c over x plus 2. All right. Now, I know up here they use A1, A2, and so on. Well, just use A, B, and C. All right? It keeps you from having to write these subscripts. All right, so what we want to do now is we have an equation, so we can multiply everything by the common denominator, by x times 2x minus 1 times x plus 2. I'm multiplying everything through by the common denominator. So when I multiply this to this term, it knocks out that entire denominator. And I'm left with x squared plus 2x minus 1 equals, and then when I multiply it to this term, I'm left with a times 2x minus 1 times x plus 2. And then I multiply it to this term, I'm left with bx times x plus 2. And then I multiply it times the last term, I'm left with cx times 2x minus 1. All right, so now, how do I figure out what A, B, and C are? That's what I need to know. All right, so I'm going to let x equal 0. All right, so you might be thinking, where in the world did 0 come from? Why did you let x equal 0? How did you know to let x equal 0? Well, I just chose x to be 0 because what happens is when I plug 0 in for x, it's going to knock this term out. See, when I plug it in for 0, I get b times 0 times 2, which is 0. And then when I plug 0 into this term, this goes out. 0 times negative 1 is 0 times c is 0. So I'm going to be left with negative 1 equals, and that's going to be negative 2a. All right, so let's just talk about what went on right there. So I took the x equals 0, I plugged it in this, and 0 squared plus 2 times 0 minus 1 gives me negative 1. And then I've already explained how this term and this term go to 0. And then when I plug 0 into here, this is negative 1 times 2 is negative 2, so that's negative 2a. And so that gives me a is equal to 1/2. So there's a. Now I'm going to let x equal, I'm going to let x equal 1/2. So why did I choose x to be 1/2? Well, by letting x equal 1/2, see this term, see 2 times 1/2 is 1, 1 minus 1 is 0, and same thing over here. So this term and this term goes out. So let's plug the 1/2 in for x, and so that's going to be 1/2 squared plus 1 minus 1. So that's going to give me 1/2 here. And then let's plug the 1/2 into here. So that's going to be 1/2 times 1/2 plus 2, which is 1/2 times, and that's going to be, what is that? 5 over 2, which is 5/4. So that's going to be 5/4 times b. And I did make a mistake here. This 1/2 here, I plugged the 1/2 in. 1/2 squared is 1/4. 2 times 1/2. So let's do it. 1/2 times 2 plus 2 times 1/2 minus 1. So that's 1/4 plus 1 minus 1, which is 1/4. So that should be 1/4. And that's what you get for trying to do it in your head. Or that's what I get for trying to do it in my head. So, you know, it might be good for you to just write it out. Okay? All right, and so now that's going to give me B is equal to, so I'm going to multiply both sides by 5/4, and that's going to give me B is equal to 1/5. All right. And now I'm going to let X equal -2. So why do I let it equal -2? Because that's going to go to 0, and that's going to make that whole term go to 0, going to make this term go to 0. So let's plug the -2 in. So let me do that. Plug the -2 into here. So that's going to be -2 squared plus 2 times -2 minus 1. So that's 4 minus 4 minus 1 is equal to -1. So that's going to be -1 equals, and then let's see, plug the -2 into this term here. So that's going to be C times -2 times 2 times -2 minus 1. So that's going to be C times -2 times -5, which is 10C. All right. So I'm going to get C is equal to -1/10. All right. So now I have A, B, and C. So now that is going to give us the integral of x squared plus 2x minus 1 over x times 2x minus 1 times x plus 2 dx is equal to the integral of all of this stuff. You see that? But what I'm going to do is I'm going to split this up into separate integrals. Remember, we can do that. We can write it as separate integrals. So that's what I'm going to do. And also what I'm going to do is this. So A is 1/2. So watch this. So that would be 1/2 over x, right? But what I'm going to do is I'm going to take the 1/2 and pull it outside the integral. So that's going to give me 1/2, 1 over x dx. And then the same thing when I plug the 1/5 in for b, I'm going to pull that 1/5 outside the integral. And that's going to be and then c is -1/10, so minus 1/10. All right, so now we're ready to integrate this thing. That's going to be 1/2, and what's the antiderivative of this? That's natural log absolute value of x plus 1/5. Now, what about this? What's going to be the antiderivative of this? Well, this is going to be what? 1/2 natural log 2x minus 1. All right. So how did I get that? Well, let's just take this integral here and come down here and let me show you. All right, so I got 1 over 2x, 2x minus 1. All right, so if you use the, and yes, there's a 1/5 out there, but we're not worried about that. I'm going to show you this. So if I let u equal 2x minus 1, then du is 2 dx. So see, I'm missing the 2 up here, so I'll multiply by 2 and then come out and multiply by 1/2. That's where that 1/2 comes in. And then you can see that's going to be 1/2, and then that's going to be du over u when we make our substitutions, which is going to be 1/2 natural log absolute value of u plus c. And then we'll take the 2x minus 1 and plug it in for u. Okay? And then for this term, that's going to be minus 1/10 natural log absolute value x plus 2, and then plus c. All right, so all I have to do now is I'm just going to rewrite this step. That's 1/2 natural log absolute value of x plus, and then I'm just going to multiply that. That's 1/10 natural log absolute value 2x minus 1 minus 1/10 natural log absolute value x plus 2 plus c. And this is my answer. All right, so let's continue on. All right, so now let's suppose we have q of x is a product of linear factors, some of which repeat. Suppose the first linear factor, a1x plus b1, is repeated r times. In other words, it's going to be written like this: a1x plus b1 all raised to the r occurs in the factorization of q of x. So the way we would write that, so if this is our denominator, then we would write it a1 over a1x plus b1 plus a2 over a1x plus b1 squared all the way to a sub r a1x plus b1 raised to the r. You would write it out that many times. So in other words, if we were looking at this as an example, so here's our denominator, x squared over x minus 1 cubed. We would see we've got 2 factors of x. We've got 3 factors of this x minus 1. So we would write it as a over x plus b over x squared. Okay, that's what they're doing here. And then we would write c over x minus 1 plus d over x minus 1 squared plus e over x minus 1 cubed. And so that's how you would expand that out. All right, so let's look at an example. All right, so let's integrate this. Well, this goes back to the first problem that we worked. The degree of the numerator is greater than the degree of the denominator. So I have to use long division here. And so I've got x cubed minus x squared minus x plus 1. And then that's going to be x to the 4th plus 0 times x cubed. We're missing that x cubed term. Minus 2x squared plus 4x plus 1. All right, so what do I multiply to this to get this? Well, that's x. So that's x cubed minus x cubed minus x squared plus x. Change the sign of each term on the bottom, and we add. So this is going to be x cubed minus x squared plus 3x, and then bring down the next term. And what do I multiply this term to get this term? Well, that's 1. And so that's x cubed minus x squared minus x plus 1. All right, now we change the sign of each term in the bottom, and we add. So that goes to 0, that goes to 0. This is 4x, and then this goes to 0. All right. So we're left with x plus 1 plus the remainder 4x over the divisor, x cubed minus x squared minus x plus 1. All right, so this is what we have to integrate here. All right, so we've got this is equal to this. All right, so I've got to integrate this thing. Well, just think integrating each term, integrating the x, the 1, and then this term. Well, I know how to integrate x. That's just 1/2 x squared. And I know how to integrate 1. That's just x. This is what I don't know how to do. I have to use partial fractions to split this up. So what I want to do, and I'm going to erase this. So what I want to do is I want to just take this term out by itself and split it up using partial fractions. Okay, and then I'll put everything back together. So first thing I need to do is factor this denominator. So that's x cubed minus x squared minus x plus 1. All right, so now I'm going to split this down the middle, factor by grouping. And so that's x squared times x minus 1. And then I'm going to factor out a negative 1. And so that's going to leave me with x minus 1 times x squared minus 1, which is x minus 1 times x minus 1 times x plus 1. Okay, factor the x squared minus 1. And so that's x plus 1 times x minus 1 squared. All right, so I have 4x over x squared minus 1, x minus 1 squared times x plus 1. Yeah, I wrote the x minus 1 squared first. No, there's no reason I did it. I just did that. It doesn't matter which one you write first. It'll all come out the same. And so this is equal to a over x minus 1 plus b over x minus 1 squared. Okay, so that takes care of this one. And now I've got the x plus 1, so plus c over x plus 1. And so now what I'm going to do is I'm going to multiply by the common denominator, which is x minus 1 squared times x plus 1. So when I multiply it to the first term, to this term over here, that's going to knock out that denominator. I'm left with 4x equals, and then this one I'm going to have a times x minus 1 times x plus 1 plus b times x plus 1 plus c times x minus 1 squared. All right, so how do I go about getting this? Well, just like before, I'm going to let x equal 1, because what's going to happen is going to knock this term out, and it's going to knock this term out. And I'll plug the 1 into here, and I'll have 2b. All right, you see that? So let's plug the 1 in for x. So 4 times 1 is 4. And then when I plug the 1 into here, that goes out. Plug the 1 into here, that goes out. 1 plus 1 is 2. And so that's 2b. So I get b equals 2. And then I'm going to let x equal negative 1. See, that's going to knock this term out. It's going to knock this term out. And I'll be left with this. Okay? So plug the negative 1 in. 4 times negative 1 is negative 4. Equals, and then negative 1 minus 1 is negative 2. Negative 2 squared is 4. So that's 4c. And so I get c equals negative 1. All right. So now, what do I do now? I don't know what a is, but I've used all my options to knock terms out. You see that? Well, a is the only one I don't know. So what I'm going to do here is I'm just going to let x equal 0. Okay? Let x equal 0. Now, where did the 0 come from? Well, I just used it. If I wanted to, I could have said let x equal 5. Let x equal 1 million. I could let it equal whatever I want. I just chose 0. So how can I do that? Well, I'm going to plug 0 in for x. And then let's look at this. Plug the 0 in for x. So 4 times 0 is 0 equals. And then I'm going to plug the 0 in here. So that's going to be negative 1 times 1, see that, which is negative 1, so that's going to be negative a, and then plus, now watch this. All right, now plug the 0 in for x into this term. So that's 1 times b, right? But what's b? b is 2. So that's 2. And let's go ahead and do this. 0 plus 1. See, I'm plugging in what I know b is, and I'm plugging the 0 in for x. And then I've got plus, well, what is c? c is negative 1. So that's negative 1 times, let's go ahead and do this. 0 minus 1 squared. All right, so that's going to give me 0 equals negative a, and that's going to be what? Plus 2, and then that's going to be, is that minus 1? And so that's going to be 0 equals negative a plus 1, so a is equal to 1. All right, so that may happen. You know, up here in this previous problem that we worked, we were able to let x equal 0, 1/2, and then negative 2, and we were able to find everything because we were able to knock the terms out. But down here in this problem, we weren't able to do that. See, we made it to where we knocked out this term, where we knocked out this term, all right? And we were able to get B and C, all right, by knocking the terms out. But then that was all we could do. But we only needed one more. We only needed to know what A was. So I just let X equal whatever, because I know what B and C are, and that allowed me to solve for A. Okay? All right. So now let's see what we've got. So we've got the integral of x to the 4th minus 2x squared plus 4x plus 1 over so all I did, I rewrote the problem again. That's all I did. And this is equal to the integral. And then I'm going to write this term out right here. That's what it equals, right? So that's going to be x plus 1 plus 4x over x cubed minus x squared minus x plus 1 dx, right? And so this is equal to the integral x plus 1 plus, and now this 4x over this, remember, that turns into this, okay? That turns into that. So I'm going to replace this part. I'm going to replace this with this right here, and plugging in 1 in for A, 2 in for B, and negative 1 in for C. All right, so that's going to give me 1 over, I got to say 1 over x minus 1 plus, and then that's going to be 2 over x minus 1 squared and then C is negative 1, so negative 1 over x plus 1. So minus 1 over x plus 1 dx. All right, so then all I do is I just integrate each term individually. And so that's going to be 1/2 x squared plus x plus, and then this is what? That's natural log x minus 1 plus, okay, now let's look at this. This right here, you may, in some of these problems, you may have to go off to the side and work it out, okay? So let's just take that part. Let's take the 2 over x minus 1 squared and integrate it. All right, so first thing I'm going to do, I'm going to take the 2 and I'm going to pull it out. And then this is just a u substitution. So u equals x minus 1. Du is dx. Okay, so see the 1 dx? There's 1 dx. That's going to be replaced with du. So that's going to be 2 integral du over u squared. And so this is 2 integral u to the negative 2 du. And so we're going to add 1, right? So we add 1, so that's negative 1, and then multiply by the reciprocal. And so this is going to be negative 2 over u. And so that's going to be negative 2 over, and then what's u? U is x minus 1. All right. And so let's see, that's going to be, I'm going to erase the plus, that's going to be minus 2 over x minus 1. And then what's this one? That's going to be minus natural log absolute value x plus 1 plus c. And there's your answer. And let me say this, another way that you might see this answer written is 1/2 x squared plus x, all right, minus 2 over x minus 1 plus the natural log absolute value x minus 1 over x plus 1 plus c. All right, so as far as how you write the answer, I don't know how your teacher's going to be. Your teacher may let you leave the answer like this, and that's fine if you do. Basically what we did, remember your logarithmic properties. I've got natural log minus natural log. Remember, when it's subtraction, it comes together as division. Remember your property, the log of m with base b minus the log of n with base b is equal to the log of m over n with base b. And that's all I did with this term and this term. I use this property right here. All right, so let's continue on. All right, so let's look at this. We've got q of x contains irreducible quadratic factors, none of which repeat, so they don't repeat. If q of x has the factor ax squared plus bx plus c, where b squared minus 4ac is negative, then in addition to the partial fractions above, the expression for rx over qx will have a term of the form ax plus b over ax squared plus bx plus c, where a and b are constants to be determined. So, for instance, let's suppose we have this, okay? We know what to do when we have the linear factors. That's the two examples we just got finished working. But look at this x squared plus 1 and x squared plus 4. These are quadratic factors. They're in this form. It's just b is 0. Okay, that middle term's not there. All right, and x squared plus 1 and x squared plus 4, they don't factor. Okay, they're irreducible. You can't factor them. Okay, so the way we write it is a over the x minus 2 And then see our quadratic factor here, bx plus c over x squared plus 1, and then dx plus e over x squared plus 4. So that's how you would expand that out. All right. So let's do an example. All right. So we've got 2x squared minus x plus 4 over x cubed plus 4x. All right. So the first thing we want to do is we want to take the denominator. We want to take the x cubed plus 4x and we want to factor it. So we're going to factor out an x and we're left with this. All right. So we have 2x squared minus x plus 4 over x times x squared plus 4. And that's going to equal a over x, see a over that x, plus bx plus c over x squared plus 4. All right, now what do? Well, just like before, we multiply everything by the common denominator. And that's going to knock that denominator out. So I'm left with 2x squared minus x plus 4 equals a times x squared plus 4 plus x times bx plus c. All right, so we got to find a, b, and c. Now, look at this. If we go and try to do this like we did before, okay, let's try to do it like we did before. We would take x to be 0, right? That's going to knock this term out. Now, if you're taking notes, don't write this down. So if we plug 0 into here, that's 4. And then we plug 0 into here, that's going to equal 4a. So we could get a equals 1. And that's fine. You can do that. Okay? But look what happens. Okay? Look what happens. I have no way of finding b and c. Because there's nothing I can plug in for x that's going to make this term go out. You see that? Because I've got x squared plus a number. X squared's always positive. So what I did before, that's not going to work. And yes, on this problem before, remember when I let x equal 1, x equal negative 1, and that got me b and c, and then I had to figure out how to get a? Well, I just let x equal whatever. And in this case, I plugged the 0 in for x, and then I plugged 2 in for b and negative 1 in for c, and I was able to get a. But down here, if I let x equal something, I'm still have the two unknowns. I've got b and c as unknown. In that previous problem, I only had the a that was unknown, just that one constant I didn't know. But in this problem, I have two constants. Two constants, I don't know what they are. So I'm going to have to do something a little bit different on this one. Okay? So, I mean, that's fine. You can leave a equals 1. That's fine. Okay? But let's go ahead and erase this. And just so you know, since that happened, okay, and a lot of times what you're going to have to do on these, where you have these quadratic factors like this, maybe not on every one of them, but on most of them, what you're going to need to do is you're going to need to multiply all this out. So that's going to be 2x squared minus x plus 4 equals ax squared plus 4a plus bx squared plus cx. And so this is 2x squared minus x plus 4 equals ax squared plus bx squared plus cx plus 4a. So all I did is I put the x squared terms together and I wrote everything in order. in descending powers. And so that's going to leave me with 2x squared minus x plus 4 equals, now this is going to be a plus b times x squared, I just factored out of x squared, plus cx plus 4a. All right, you see that? So now what I have is I have a plus, and I'm going to write this over here. I've got a plus b is equal to 2. I've got c is equal to -1, and I've got 4a equals 4. Now, where in the world did that come from? Well, look at this. You see the a plus b? That's the coefficient of x squared. That has to equal this coefficient. And then you see the coefficient of x, that has to equal the coefficient of x. And then this constant right here has to equal this constant. You see that? And so that's where a plus b is equal to 2, c is equal to -1, and 4a is equal to 4. And so now you can see, just like we did earlier, a is 1, c is -1, and now I've got a plus b is 2. Well, I know a is 1, so 1 plus b is equal to 2, so b is equal to 1. All right? And so now I can plug all of this into here. So I've got the integral 2x squared minus x plus 4 over x times x squared plus 4 dx is equal to, and that's going to be the integral. All right, so let's see what we've got. We've got 1 over x dx, and I'm going to split them up, okay, because I'm going to integrate each one of these, and then that's going to be plus the integral of, so b is 1, so that's going to be x plus c is -1, so instead of plus, that'll be -1 over x squared minus 4 dx. Now, I've got to integrate this thing right here. Well, I don't know how to integrate that, but what I do know how to do is I do know how to split it up. Okay, you see that? I know how to split it up like that. All right, and you know something? I have no idea why I wrote minus. That should be a plus. Not x squared minus 4, x squared plus 4. All right. We've been in this video a while. My mind's starting to go, I guess. All right, so it's x squared plus 4. All right, so now let's integrate this. Well, before we integrate this, I want you to recall that the integral of dx over x squared plus a squared is equal to 1 over a times the inverse tangent of x over a plus c. All right, so hopefully you remember this property here. All right, so let's go through and start. Let's start integrating. So the antiderivative of this, that's natural log absolute value of x. All right, so now we need to integrate this thing. Well, this is just a basic u substitution, and I'm gonna come down here and do it. So let's just take this x over x squared plus 4 dx. So u equals x squared plus 4 du is 2x dx. Well, I need the 2 multiplied by 1/2. So you can see that's going to give me 1/2, and that's going to be du over u. which that's natural log. All right. And so this is going to be plus 1/2 natural log absolute value x squared plus 4. All right, and let me say this on this right here. Now I put absolute value, but look, you can put parentheses on this. And how do we know we can put parentheses there? Well, because x squared plus 4 is always positive. Isn't that what the absolute values are for? To make sure that we're taking the natural log of a positive number. Okay. All right, and then we've got minus. All right, so can you see that this is in this form? See, look, I can take the dx and I can put the dx up here just like this. And you see the 4 here? Well, that 4, that's the same thing as 2 squared, right? So you can see it's in this form. So here a is 2. And so that's going to be 1/2 inverse tan x over 2 and then plus c. And there's your answer. All right. All right, so let's see what we've got next. All right, so how about this one? We got another example. Well, first thing I notice here is the degree of the numerator is not less than the degree of the denominator. All right, remember that's what we got to have. See, like in this problem up here, see how the degree of the numerator is less than the degree of the denominator? And remember, we talked about this at the first of the video also. They're the same. So first thing I need to do is long division. So that's going to be 4x squared minus 4x plus 3. And that's going to be 4x squared minus 3x plus 2. All right, so what do I multiply to this term to get this term? Well, that's 1. So that's going to be 4x squared minus 4x and then plus 3. Change the sign of the second terms and add. So that's going to be x minus 1. So this is equal to 1 plus, and then x minus 1 over 4x squared minus x plus 3. All right, so I'm going to integrate this thing. Well, I already know how to integrate 1. It's just this that I'm having problems with. Okay, so remember what we do. We factor, right? We factor. Well, that denominator doesn't factor. All right. So what we want to do is we've got 4x squared minus x plus 3. And what I'm going to do is I'm going to, wait a minute. That should be minus 4x plus 3. Minus 4x plus 3. So what I'm going to do here is I'm going to rewrite this as 4x squared minus 4x plus 1 plus 2. I just rewrote the 3. I rewrote 3 as 1 plus 2. And so that's going to be 2x minus 1 squared plus 2. All right, see, that's a perfect square trinomial. That factors into 2x minus 1 times 2x minus 1, which is 2x minus 1 squared. All right. So what I have now is I have 4x squared minus 3x plus 2 over 4x squared minus 4x plus 3 dx is equal to, and that's going to be the integral of 1 plus x minus 1 over 4x squared minus 4x plus 3 dx. Okay, see this is equal to all of that. But then what did I do? I rewrote this right here as this. So I'm going to replace this with 2x minus 1 squared plus 2. All right, so how do we go about working this problem? Well, let's make a substitution. Let's let u equal 2x minus 1. We're going to let it equal that. And before I guess we can just leave it like that. Well, let's do this. Let's write this as 1 dx plus, let's split the integral up, x minus 1 over 2x minus 1 squared plus 2 dx. And so I'm going to let u equal this 2x minus 1, so du is equal to, that's going to be 2 dx. All right. All right, so what do we do now? All right, so look at this. We're going to take the u and we're going to plug it in for 2x minus 1. Okay, so that's going to be u squared. But see how I have this x up here? I'm getting everything over here. I'm getting it all in terms of u. Well, if we solve this equation for x, that's going to give us u plus 1 equals 2x. So x is equal to 1/2 times u plus 1. All right. And then this one, that gives me dx is 1/2 du. You see that? So let's make all those substitutions. So that's going to be dx plus, and then that's going to be the integral. Now, in the place of x, I'm going to put 1/2 u plus 1. 1/2 times u plus 1 minus 1 over, and then that's going to be u squared. That's going to be u squared plus 2. And then in the place of dx, see what's dx? Dx is 1/2 du. 1/2 du. So I just made all those substitutions. All right. See how much room I got? Yeah, I got enough room. All right. So this is going to be the integral dx plus. Now let's just write all this out and show all these steps. So that's going to be 1/2 u plus 1/2 minus 1 over u squared plus 2 du. And this 1/2 right here, I'm going to pull it outside the integral. All right. And so then we've got integral dx plus 1/2 integral. That's going to be 1/2 u minus 1/2. 1/2 minus 1 is negative 1/2. And that's going to be u squared plus 2 du. And so this is going to be the integral dx plus 1/4. I'm taking the 1/2, I'm factoring out a 1/2, so that would give me 1/2 times u minus 1. And then I'm bringing the 1/2 outside the integral to make that'll be 1/4. That's the integral of u minus 1 over u squared plus 2 du. All right. All right. Now, once again, this doesn't help us any right here. So what I'm going to do is I'm going to split it up. And that's going to be 1/4 integral u over u squared plus 2, and that's du, minus 1/4 integral 1 over u squared plus 2 du. Squeeze that in there. All right, so I just split this up into these two fractions here, and don't forget to put the 1/4 on both of them. All right, so this, let's go ahead and integrate. So that's going to be x, that's the antiderivative of this, plus 1/4. And then what is this? Okay, we did a problem like this earlier. That's going to be what? 1/2 natural log of what? Absolute value u squared plus 2, right? All right, and I mean, and yeah, we don't have to use absolute value because that's always positive there. All right, and then I've got minus 1/4. Oh, what is this? This is what? That's inverse tangent. Where, remember, this 2 here can be written as square root of 2 squared. So a is square root of 2, right? So this is going to be times 1 over a times the inverse tangent of x over a plus c. And then what do we have to do? Then we have to make our substitutions. And I'm sorry, that's not an x, is it? That's a u. And then we have to make our substitution, right? We've got to make our substitution. Well, what is u? U is 2x minus 1. So in the place of u, we're going to put 2x minus 1. So that's x plus 1/8 natural log 2x minus 1 squared plus 2 minus 1 over 4 square root of 2 times the inverse tangent of 2x minus 1 over square root of 2 plus c. And then if we take this and multiply this out, well, 2x minus 1 times 2x minus 1, that's x plus 1/8. And then if we FOIL that, we do the 2x minus 1 times 2x minus 1, and then multiply that out and then add the 2 to it. Add this 2 to it. I'm not going to show the work, but you'll end up with 4x squared minus 4x plus 3. And then minus 1 over 4 square root of 2 times inverse tangent of 2x minus 1 over square root of 2 plus c. And so you can see in this problem, did we use partial fractions? No. All right. Look, what students tend to do is whenever they get to that section on partial fractions and they learn how to do the partial fractions, anytime they see a rational expression, that's automatically the first thing they go to is partial fractions. And that is not the case. Okay? That's not the case. You only use partial fractions if you have to. If you can do it some other way, then do that. Okay? And in this case, this, the denominator didn't factor. All right, so let's continue on. I don't think we have a whole lot left, so just bear with me. All right, so we've got q of x contains a repeated irreducible quadratic factor. Okay, so look, what did we start out with? We started out with a linear factor. That was the first thing we did. And then we did the linear factors repeated. Remember, in parentheses, raised to a power. And then we did quadratic factor. That was the last example, but we didn't use partial fractions, but the example before that, okay, we have quadratic factors that didn't repeat. Now we have repeated quadratic factors. So if q of x has the factor ax squared plus bx plus c all raised to the r, where b squared minus 4ac is less than 0, then we have this. Okay, so it's a1x plus b1 over that, a2x plus b2 over this squared all the way to where it's to the r power. So let's look at this example. So we're not integrating this one. It just says write out the form of the partial fraction decomposition. Okay, so if we have x cubed plus x squared plus 1 over x times x minus 1 times x squared plus x plus 1 times x squared plus 1 cubed. We just want to write out that partial fraction decomposition. Okay, and so that would be a over x, so that's a linear factor, plus b over x minus 1 plus, that's that factor, and then we have a quadratic factor here, so that's going to be cx plus d over x squared plus x plus 1. And this doesn't factor, but it's a quadratic factor, so we can write cx plus d over that, plus, and then we have this term. We have 3 of those. So that's going to be ex plus f over x squared plus 1 plus, and then we've got to do it again to the second power. So that's gx efgh over x squared plus 1 squared. And then I've got a third factor, so that's ix plus j over x squared plus 1 squared. And that's all they're wanting in this one. Now that problem would be kind of nasty trying to solve that thing. So we're going to leave it like that. And that's all they wanted us to do, is just write it out. All right, now let's look at a problem. All right, so we want to integrate this thing. So we've got 1 minus x plus 2x squared minus x cubed over x times x squared plus 1, all of that squared. All right, so the denominator, it's already factored for us and everything. So we've got 1 minus x plus 2x squared minus x cubed over x times x squared plus 1 squared. That's going to be a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 squared. All right, and then what do? We multiply everything by the common denominator. So that's going to knock that term out. So that's going to leave me with negative x cubed plus 2x squared minus x plus 1. I just rewrote this numerator in descending powers. Okay, if you didn't do that, it wouldn't be that big of a deal. All right, and that's going to equal a times x squared plus 1 squared plus, now this is going to be x times x squared plus 1 times bx plus c plus x times dx plus e. All right, so this is going to be similar to that problem we worked where, what are you going to let x equal? Okay, you let x equal 0, that'll get us a. Okay, that'll tell us what a is. But we still don't know what B, C, D, and E are. And there's nothing else. What am I going to let x equal to knock out these x squared plus 1 terms? Well, you can't. Okay? So we're going to have to multiply it all out. So that's going to be negative x cubed plus 2x squared minus x plus 1 equals, now this is going to be a times x to the fourth plus 2x squared plus 1 plus, and then that's going to be x times, and that's going to be bx cubed plus cx squared plus bx plus c. I just foiled these two, okay? Multiply, make sure I didn't mess up anywhere. Bx cubed plus cx squared plus bx plus c, okay? And look, I mean, just go slow when you're doing this. I mean, it's just a lot of stuff in here, and you know, you just got to be careful and make sure you don't mess up. And so that's going to be plus dx squared plus ex. And so now I'm going to have to distribute. So negative x cubed plus 2x squared minus x plus 1 equals ax to the fourth plus 2ax squared plus a plus bx to the fourth plus cx cubed plus bx squared plus cx plus dx squared plus ex. And then I'm going to go ahead and get all the common exponents together. Ax to the fourth plus bx to the fourth. And I'm gonna mark these out as I go. Okay, so that's all I'm gonna do in this step. I'm gonna pause the video while I do that. All right, so I went ahead and I just wrote the common exponents next to each other. All right, so now I get negative x cubed plus 2x squared minus x plus 1 is equal to, so that's going to be a plus b times x to the fourth plus cx cubed plus 2ab plus d times x squared. So I just factored out x squared right there, plus c plus e times x plus a. All right, so let's see what we've got. We've got a plus b is equal to what? 0. There's no x to the fourth term, so that has to equal 0. I get c is equal to negative 1, so we've got c. C x cubed, c has to be the negative 1. And then I get 2a plus b plus d. That's the coefficient of x squared, which is 2. And then I get c plus e. The coefficient of x is negative 1. And then I get a is equal to 1. So let's see. So if a is 1, look at that. That's 1 plus b equals 0. So b is equal to negative 1. And I know a, I know b. See that? I know a, I know b. I plug that in and get d. So a is 1, so that's 2 times 1 is 2 minus 1 plus d equals 2. So that's 1, so d is equal to 1. I know c is negative 1, so negative 1 plus e is equal to negative 1, so e is equal to 0. All right, so now what do? We plug all of those into here. You see that? So what I'm going to do is I'm going to write that here. That's going to be, let's see, that's going to be a over, was it a over x? And then bx plus c, bx plus c over, was that x squared plus 1, and then plus dx plus e over x squared plus 1 squared. Okay, so all I did is I just recopied this. Okay, so we can have it down here so we can see it. And then we plug everything in. So we've got the integral, and all I'm going to do here is I'm just rewriting the problem. That's 1 minus x plus 2x squared minus x cubed over x times x squared plus 1 squared dx. All right. And that is equal to a over x. Okay, that's going to be the integral. A over x, and a is 1, so that's 1 over x plus, and now let's plug the negative 1 in for b, negative x minus 1, see, negative 1x minus c is negative 1, over x squared plus 1, plus, and then for d I'm going to plug in 1, so that's going to be 1x plus 0 over x squared plus 1 squared dx. All right, so let's integrate all this. And so this is going to be the integral of 1 over x dx, and then plus, now let's do this. I'm showing more steps than I probably should, but I'm just going to show them anyway, because I mean you're learning this, so let's just show all the steps so you can see what's going on. I'm going to factor out a negative 1, so that's negative integral x plus 1 over x squared plus 1 dx plus the integral of x over x squared plus 1 squared dx. And then this one I'm going to split up, and so that's going to be the integral of 1 over x dx minus the integral of x over x squared plus 1 dx minus, don't forget to bring that minus, it's like you're distributing that minus, the integral of 1 over x squared plus 1 dx plus the integral x over x squared plus 1 squared dx. Okay, and so now we're ready to integrate. So this is going to be the natural log absolute value of x. Okay, now this one we've already done this several times like this, so that's minus what, 1/2 natural log x squared plus 1, and then minus, now what is this? That's the inverse tangent. A is 1. And so that's what? 1 over a times the inverse tangent of x over a. See that? Plus, and then this one, we've already done this one. I guess we'll just do it again, just real quick. Okay. U is x squared plus 1, du is 2x dx. So we need the 2, 1/2. You see that? So that's going to be 1/2. Plug the u in and the du. That's going to give us u to the negative 2 du. So that's going to be 1/2 u to the negative 1, 1 over negative 1. And so that's going to be negative 1 over 2 u. And then we got to plug the x squared plus 1 in. And so that's going to be, instead of plus, it's going to be minus 1 over 2 times x squared plus 1. And then plus c. And so here's your answer. And yes, ideally, you don't want to leave that as 1 over 1. You'll just take that off, and you don't want to write that as x over 1, so you'll just write that as x. All right, and there's your answer right there. All right, so this problem, this is actually, I think this is the last one, or maybe not. Let's see. No, it's not the last problem. All right. So let's look at this one. So the first thing you think of, partial fractions. Okay, You're going to rewrite this as a over x plus bx plus c over x squared plus 3. All right. So, and if you do that, perfectly fine. Nothing wrong with doing it. It may be difficult to solve. I don't know. But do you remember what I've told you a couple of times in the video? The partial fractions, integration by parts, all that stuff, that is a last resort. Okay? This is equal to what? X squared plus 1 over what? X cubed plus 3x dx, if I distribute that. Now, why in the world did I do that? Well, because I noticed that if I have this x squared here, if I distribute that, that'll be x cubed. What's the derivative of x cubed? 3x squared. Okay. Yes, I have this plus 1 here. That might be a problem. I don't know, but let's see. What happens if I do u substitution? Let u equal x cubed plus 3x, and then that's going to give me du is equal to 3x squared plus 3 times du. Oh, look at there. Du, if I factor a 3 out, that's x squared plus 1 du. Look at that. You see there? That's the kind of things that you want to try first before you go into partial fractions. Okay? So all I have to do here is multiply by 3 and then come outside and multiply by 1/3. And now the 3x squared plus 1 dx, I have my du here. And I'm sorry, I don't know why I wrote du there. That's dx. All right? You see that? And so now we have the integral 1/3, and that's du over u. See, we're making the substitution. That's du. And then I'm going to plug u in for this. And so now I got 1/3 natural log absolute value of u plus c, which is 1/3 natural log absolute value of x cubed plus 3x plus c. And there's your answer. And you can see that was a lot easier than doing the partial fractions. All right, so this is the last problem. So let's take a look at it. All right, so how about something like this? Well, obviously this doesn't look like any of the problems that we've worked before. So, we're going to have to make some substitutions, okay? So I'm going to let u equal the square root of x plus 4. And so that's going to tell me u squared is equal to x plus 4, right, if I square both sides. And notice I have an x here. So I know that x is equal to u squared minus 4. If I differentiate, we can differentiate that. That's going to give me dx is equal to 2u du, right? If I differentiate that, that's dx and then 2u du. So now let's make our substitutions and see what we get. So that's going to be u over u squared minus 4. And then let's see, the dx, in the place of dx, I've got to put times 2u du. And so that's going to be the integral of, and I'm going to bring the 2 out. That's going to be u squared over u squared minus 4 du. All right, so what we've got here is we're going to have to do partial fractions on that. So you can see the exponents are the same. You see that? So we do have to use long division. Okay. We will have to use long division, and I'm not going to show the work on the long division. I've shown the work on the long division a couple of times already. So I'm just going to write that out. That's going to be 1 plus 4 over u squared minus 4 du. Okay. And then we'll need to use, we know the antiderivative. We know how to integrate 1. It's just this one right here. All right, so what do we do there? Well, we'll have to do the partial fractions. So let's take just this piece right here, and this shouldn't be a very difficult one. So that's going to be 4 over u minus 2 times u plus 2. Go ahead and factor it. So that's going to be a over u. That's going to be a over u minus 2 plus b over u plus 2. And so we multiply by the common denominator, and that is going to give us 4 equals a times u plus 2 plus b times u minus 2. And then here we'll let u equal negative 2. So that's going to be 4 equals negative 4b. So b is equal to negative 1. And then u equal 2. So that's going to be 4 equals 4a. Plug the 2 in for u. And so that's going to give us a is equal to 1. And so now I have 2 times the integral of 1 plus. Now I'm going to rewrite this in this form right here. See that? I'm going to replace this with this right here. So in the place of a, I'm going to put a 1. And so that's going to be 1 over u minus 2. And then b is negative 1, so minus 1 over u plus 2. And then that's all du. And so now let's integrate this thing. And so that's going to be 2 times, and that's going to be u plus natural log, and that's going to be absolute value u minus 2 minus natural log absolute value u plus 2 and plus c. All right. But what do we have to do? What do we have to do here? Well, that's a C right there. Our problem wasn't in terms of u, it was in terms of x. So you can see here u is square root of x plus 4. See, u is square root of x plus 4. So we got to plug that in for u. So that's going to be 2 square root x plus 4. See that? Plus 2 natural, I'm distributing the 2 as I go. 2 natural log absolute value square root of x plus 4 minus 2 minus 2 natural log absolute value square root of x plus 4 plus 2 plus c. And there's an answer right there. And then, you know, like we did before we distribute the 2, we could have written this. See, I mean, this is a good answer here, but what we could have done here is we could have gone to this instead. Let me show you. Okay. We could have rewritten this as 2, and then that's going to be times, and then square root of x plus 4 plus natural log absolute value. Now I'm going to plug the square root of x plus 4 in for u. Square root of x plus 4 minus 2 over square root of x plus 4 plus 2, okay, plus c, and then I could have distributed the 2. So, you might see an answer written like this. That's the reason I'm showing you this, is because when you go to the back of the book and look, you might see this as an answer. And you'll be sitting there wondering, well, where in the world did that come from? Well, that's what it is. It's just a little simple algebra they did, okay? So, I'm sure this answer may be good for your teacher. I don't know. It may not be. Or they may want this. And if that's what they want, then, just go ahead and, when you're at this step, just go ahead and rewrite this part right there. Rewrite this right here as a single log. So finally, that's it. That's all of integrals of rational functions by partial fractions. So, if you made it to the end, leave a comment. Let me know. I'd be curious to see how many people stayed till the end to watch it. But hopefully this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.